remember, we talked about air molecules, warm and cold air molecules. So here's my visual. We have molecules spread far apart that represents, yes, warm air. And then we have molecules that are packed tighter together that represents cold air. Because they're packed closer together, it makes them more dense. They want to sink. Because they're far apart, they are less dense and they want to rise. I'm going to show you an experiment now that's going to prove that things that are cold want to sink and things that are warm want to rise. So here I have my ice cube that I've put food color in blue. That's going to represent the cold. And then I've got my little bottle. I'm going to put hot water in with some red food color to represent the hot. And then we're going to put those both into this container, and you're going to see the cold blue molecules sink, and you're going to see the red warm molecules rise to the top. So I'm going to mix up my hot water with the red food color. Add a few drops of red. Shake it up. And now I'm going to put the cold blue ice cube in the room temperature water, and then carefully place my hot water in, and you're going to watch them separate. So watch as the blue represents cold, it is the ice cube, is sinking. And the red food color, hot water, is staying at the top. So we're going to watch a few minutes and just see how this plays out. So as you can see, the red or the hot water is starting to sink down. Why is that? Well, it's cooling off and becoming more dense. The cool water, the ice cube melting, is starting to come up just a bit because it is getting warmer. But another thing I want you to think about, up in the atmosphere when this happens, that's what we would call a front. These two air masses are meeting. This isn't a very turbulent one, but up in the sky, when it's a lot different in temperature, then we would have stormy weather. So it's just kind of cool to watch that cold water sinking to the bottom and staying at the bottom, and then the warm water coming to the top. So what would happen in a few minutes if we kept watching? Eventually all this water would turn to room temperature and it would all mix. So as you look at the air molecules, notice in the warm air, as we've stated before, they are spread far apart. That gives there more room for moisture and wind and other types of weather to occur because the molecules are far apart. And I'm going to demonstrate that with my 3 jars. I've got a jar of pretty hot water, room temperature, and then cold water. I'm going to put a couple drops of food color in each jar. What I want you to observe is how quickly or slowly the food color disperses in the water. Water acts a lot like air. So this is the same thing happening up in the atmosphere. So let me put my drops in. Okay, so watch as I put a couple drops of food color in the hot water. Watch how quickly or slowly that food color moves. Look at the room temperature, how fast or slow it moves, and then the cold. Again, you're looking for how quickly or slowly the food color is dispersing in the jar. As you look at the hot water, remember those molecules are spread far apart, so there's a lot more activity and action going on. That means that food color can move more rapidly. If you look at the cold, the molecules are packed close together, so there's not a lot of room for that food color to make movement. And then in the room temperature, because it's warm, it is moving kind of quickly, but not as fast as the hot. I love this demonstration because it really does prove and show in the atmosphere when the air is hot, that's when we have our storms because the molecules are spread far apart. So as we talk about storms this week, two of my favorite words when it comes to weather are tornadic and vortex. Now, vortex is a spinning mass of air, mass of water, could also be some fire as well. So with my two bottles here, I've joined together, I'm going to spin the water, turn it upside down, and create a vortex for you to see. So I'm going to spin my bottle and show you a vortex. And that's how a tornado would look in the sky. Thanks for watching this week. And don't forget, if you haven't already, like and subscribe.